Hi guys, welcome to the CS Classroom. This is part 1 of my new course that will prepare you for the AP Computer Science A exam. Let's get started. What I first want to do is talk a little bit about the structure of this course and their individual components. So this course is going to focus on Java for the AP Computer Science A exam, and it aligns with all of the exam requirements. So in this course, it's probably going to be about 9 or 10 parts. You're going to have everything you need to get a 5 on the AP Computer Science A exam. It requires 0 prior knowledge, so particularly in the first couple of parts, we're just going to be going over some really basic concepts that are on the exam, but will also just help those who've never done any programming before wrap their head around everything. In this course, I'm heavily going to incorporate examples, programming exercises, and also exam-style practice. So in some of the earlier sections, we may not have as much practice taken directly from sample questions, but we will have exam-style questions to build you up to being able to solve real AP Computer Science A questions. This course is intended for anyone who will be taking this course, is in the middle of this course, or is about to take the exam. So if you haven't taken the course yet, this can be a great way to get a step up and just kind of get some early exposure to programming concepts that'll be useful for the exam. Or if you're already taking the course, it can be a useful way to fill in the gaps and just get a different perspective on some of the material in the AP Computer Science A curriculum. Now, all of the slides that I use in these videos will be linked in the description. And what I would recommend doing is actually opening up the slides, which are in Google Slides, and going through them while you're watching the video. This way you can kind of pause, do the exercises, and just kind of take some time to go through the concepts that are presented on the slides. Now, before we actually get started with the coding itself, I want to talk about how we're going to execute our code in this set of tutorials. So there are 3 ways in which you can run code. One is through a website called repl.it. The second is through Visual Studio Code, which is a program you can install on your computer. Third is manually. And the fourth is just writing code on paper. So what we're going to do in this particular tutorial is work with repl.it, which is the first one right here. And what I would encourage you to do as well is to write code on paper, because on your exam, you're going to have to write code on paper. So it's good to get into that habit without any of the aids that a code editor or repl.it will give you. That being said, let's open up repl.it.com real quickly so I can kind of show you how it works if you haven't used it before. So right here, repl.it.com, what you're going to do first is log in. And you can continue with pretty much, you can create an account, or I'm just going to continue with Google. And that'll log you right in. And what you want to do first is you want to wait for it to load. Sometimes it takes a while. And then just do create REPL right here. So you can do create REPL, and then right here where it says search templates, these templates correspond to different programming languages. So we're just going to type in Java, and we're going to choose Java, and then we're going to name, what this is basically doing is creating a Java file for us. And we're going to call it file practice. And we can go ahead and just click create REPL. And what this is actually doing is this is just creating a Java file for us. And in this website, we can execute, we can run all the code and all of our programming exercises here without having to install anything on our computer. And that's why I recommend it, and that's why I'm going to be using it during this particular tutorial, because it's the fastest way to get up and working. That being said, you can also download Visual Studio Code and install it, but especially if you're not sure whether you want to take this course or you're just not good with just, I don't know, installing stuff on your computer, repl.it is the easiest way to go. Now let's get started with the content of this course itself. I want to start by talking a little bit about Java. So what is Java? Java is a programming language that was created in 1991. And so the idea behind Java was that the people that created it wanted a programming language that they could run on any type of device. So initially it was made to run on set-top boxes that were connected to people's TVs, kind of like DVR. But nowadays you can find it on websites in the form of Java applets. You can find it on Android phones. It's used heavily in desktop. It's used in large applications that run on servers. You can find Java pretty much anywhere nowadays, and that's the reason it was created. It's a C-based language, meaning that it's similar to other languages like C++ or C. So if you've seen those languages before, you might have a step up here. It's a high-level programming language, meaning that the type of code, or the code, resembles natural language, so languages like English. If you know English, actually, it's not really going to help you that much. I mean, you still need to learn a lot about coding, but it is a high-level programming language, so it'll make it a little bit easier to associate certain code words, the words you already know. And finally, Java is an object-oriented programming language. I don't expect you to know what this is right now, and I'm not going to explain it in too much depth. It uses something called objects to store and organize information, and that's a really big part of not only why Java is useful, but also what's going to be asked on the AP Computer Science A course, or exam. So at the moment, don't worry too much about object-oriented programming, what object-oriented programming is, but just know that we're going to be spending a lot of time with this concept in future lessons. So we're going to be executing our first program right here pretty soon. And if you go to repl.it, this is kind of where our files are stored. Let's see if I can go ahead and do that. And basically what happens is we're starting with a main.java file. So anytime you write code, it's going to be stored in a file that is .java. And in repl.it, we're just going to run that file. So sometimes it takes some time. And what this program was meant to do was to output hello world, and it did that. But basically what happens when we want to run this Java program is we are using something called a compiler, and that compiler is represented by this Java C command right here. So we're taking our Java file, we're putting it through a compiler, and that's turning it into something called bytecode. Bytecode is just another type of code, but it's not really code that we as humans can easily read or work with. So we go from a .java file to bytecode via a compiler, and then that bytecode that we've generated goes to something called a Java virtual machine, which is going to be stored on your computer. In the case of repl.it, that's stored on their servers, but basically bytecode goes into the Java virtual machine, and then from the Java virtual machine, we get binary code. Binary code is just ones and zeros, and it's the lingua franca of computers everywhere. So this binary code goes straight to your CPU, to the processor in your computer, and then we get some actions. We get a window opening, we get hello world printing, or we get some graphics on our computer screen. And that's basically how Java works. We're going to be writing code in files like main.java. It's going to get compiled, and then that compiled code is going to be turned into binary, which gets run on your processor. Now, we can't really see it right here, strangely enough, but that bytecode is going to live in a .class file. So even though we can't see it, we would have a main.class file, and that's what's going to get converted into binary. Now, one other thing to keep in mind is that we're going to be working in this console right here. And this console is similar to the terminal on a Mac right here. So this is a terminal. And if you're working on a Windows computer, that's a command prompt. Now, all that really is a way to control what's going on your computer through commands. And this is the most basic way to input data and output data on a computer. Things like icons or a graphical user interface like what we have right here, those are a lot more higher level. And it takes a lot more code and a lot more knowledge of Java in order for us to create programs that look like that. So the most basic problems output stuff to our terminal or our command prompt, or in this case, the console. And largely when we're working with programs in our exercises, we're going to be inputting and outputting stuff to our console right here. This is an example of a line of code that outputs something to a console. In this case, it's just outputting a string, hello world. A string just means text. Now that being said, let's get started with Unit 1 of the AP Computer Science A curriculum, which is on something called primitives. Now, we're not going to be covering all the units in order, but we will be covering all of the units at some point in time. So if you see me skipping around, don't worry. In this particular unit, we're going to write our first Java program. We're going to understand the basic structure of a program. We're going to get into variables and data types, arithmetic operations, and finally, we're going to learn about something called casting. If you don't know what any of those are, stay tuned and I'll explain all of those concepts to you in detail. Now, for our first program, we want to print out the string hello world. So we're going to use this code right here. Wait, I guess we already did that, didn't we? So right here, we did print out hello world. But what I'm going to do is I'm going to take this opportunity to explain this, to kind of explain what's going on in this particular file in more detail. So this file is called main.java. And as a result, we're going to have class main right here. So we have the class keyword, and then we have main, because that needs to match the name of the file. So main.java, class name. Like not main.java, class not main. And then we've got braces, which means all of the code inside is going to be inside this class. Don't worry what a class is at the moment, we'll go through it later, but you just need to know to use this because in order to start out all of our programs, we're going to have class and then something. Then we have public static void main string args. Again, this is something that you really don't need to understand at the moment, but again, here we have braces, and our code needs to sit inside of these braces. So at the moment, this is the only line of code inside these braces, and this is what's going to get executed when we run this file. Now right here we have our output, which is just hello world. If we want to change this, we can just change the text in here. Text in Java is represented in quotes, and that also signifies that the text is a string. So whenever we want to use some text in Java, we're going to put that text in double quotations to make it what's called a string. And I'll explain more about what that is later. But what I can do now is I can say, instead of hello world, hello new student. And this command is system.out.println. So basically you can think of the out as meaning output, the system as meaning computer, and then println meaning it's printing a line of text. So I change it to hello new student. Let's run it again. Yep, right here we've got hello new student. Now just keep in mind, for every exercise we do, we're going to have class. We're going to have the name of the file as the class name. Then we're going to have this public static void main. That's going to change a little bit as we get further down, but at least for the next couple of units, this is what we're going to be working with. If you manage to do this with me and write this code in repl.it, congratulations, you just created your first program. Let's do something a little bit more complex. Now we have hello new student. Let's say I want to print out something else. I'm gonna start by creating a variable. So I'm going to say string animal equals dog, and then semicolon. Now what's important is that every line of code that doesn't have a brace like this, where we're making a statement, is going to end in a semicolon. That tells Java that you're done with that particular line. So string animal equals dog. We're creating a variable called animal that is of type string, and we're giving it a value dog. Now, this word variable that I'm using, you may have never heard in this context before, but it's really similar to a variable in mathematics. We have something that represents another thing. And now we're going to do system.out.println, and we're going to type in animal right here. Now we know animal represents dog, and dog is a string. So let's see what happens now. Notice right here, I'm not putting text in as I did before. I'm just putting the variable animal. And right here, we printed out dog. Now, what I want to do is, now that I'm kind of giving you an example of what variables are, I'm going to explain them in more detail. So a variable is a storage location that has a unique name and value. Now, this storage location is located in your computer's RAM, or random access memory. Now, if we look at this chart right here, our RAM sits between our hard drive and our CPU. Our CPU is responsible for conducting any operations in our computer. It's like the brain of our computer. And our hard drive contains all of the data that we use. But whenever we want to run a program, what our CPU does is it takes it out of our hard drive and then puts it into our RAM. So any programs that we're currently running or any work that we're currently doing, that's all the data for that is being held in our RAM. And when we turn our computer off, our RAM is wiped clean. When you turn it back on, it's back in business. Our hard drive is more, if we think about like the computer as a human body, our CPU is like a brain, our hard drive is like our long-term memory, and our RAM is like our short-term memory. We take something out of our long-term memory and then bring it to our short-term memory when we want to lose it or we want to use it. Then after a while, it goes back to our long-term memory. Same is true of our hard drive, RAM, and CPU. So that's being said, let's go back to variables. Now, variable is a storage location that has a unique name and value. And when we create a variable, we're allocating memory in our RAM for the data held by this variable. Now, if we look at this example right here, we have a variable named animal and its value is dog. When we created this variable on this line right here, what we did is we allocated some space in memory and stored dog there. Additionally, having allocated that space in memory, once we, when we wanted to, well, we basically store that data right there in memory, right? But when we go to use animal again, what we're doing is we're going back to that location in our RAM, in our memory, and we're bringing that data back, which is dog, and then using it in some way. In this case, is printing it out. So variables are all about memory. What you do need to know at a baseline is that variables are a way for us to store data in our program and then make use of it later. Now we have a few other terms: identifier, which is just this name animal, that's an identifier. Value, which is what we're actually storing in the variable. Assignment statement, so that's just this equal sign. So what we did right here is we created a variable called animal, and then we gave it a value of dog. And the act of giving this the act of basically assigning this value dog to this variable is done through this equal sign right here. And that's an example of assignment, and that makes that equal sign an assignment statement. These two we'll go into a little bit later, CamelCase and constant. But at least for the next 10 or so minutes, we're going to be working with all of these different concepts right here. So if you didn't understand exactly how they factor into writing Java programs, don't worry. Now, as far as creating a variable, there are a few things that you need to know. So anytime we create a variable, we're going to have three things. We're going to have a data type. In this case, it's a string, meaning text, and that's indicated by quotes. We'll have other data types we'll work with, like integers and doubles, which just mean decimals. But we're going to have our data type first. We're going to have the name of our variable, and then we're going to have the value of that variable. Now, if we just do something like this, string animal, that's declaring a variable. If we do this, that's initializing a variable. Now right here, we create a variable. What we can do instead of this is we can do string animal. And in that case, we're just declaring a variable. We're creating it, but we haven't assigned any value to it. So that memory is allocated. We have that memory location in our RAM, but we haven't, there's like nothing there. So this is just declaring. And then we can initialize it. We can say animal equals dog, semicolon. And now we're pretty much going to get the same output. We're just going to get dog. So declaring and initializing, or we can do this all in one line. But it's really important that we do this before we can use the variable animal. If we're missing any of these parts, well, I guess we don't need the value, but if we're missing that, for example, it's just not going to work. We're going to have an error. So in order for us to be able to use a variable, we first need to declare that variable and then assign it a value. So that's how we create a variable. We went over kind of how memory works. Now, one thing I want to talk about now is constants, but I think before I do that, I want to play around with variables a little bit more. So right here we had string animal equals dog, right? Let me print that out. What is cool about variables is after we assign it a value, we can change it at any time. So right here, if we have string animal equals dog, and then we want to change the value to, let's say, animal equals cat. If we print that out again, we do system.out.println and then animal. Let's see what happens. Okay, we had dog, which is printed with this line of code, and then we have cat, which is printed with this line of code. Now, one thing I want you to keep in mind is that a program is basically a series of instructions, okay? So When we're going to this program, what we're doing is we're executing this line, then this line, then this line, and this line, one after the other in sequence. So first off, we created our variable and we assigned it a value of dog. Then we printed out the value of animal. Then we changed the value of animal to cat. Then we printed out the value of animal again, which is now cat. And in this way, we can change values of variables quite easily. Now, kind of getting back to that concept of data types, right here we're working with a string. Now, let's talk about what happens if we're working with an integer, for example, which is just a whole number. What we can do is we can change this from string to int. And let's say we want to work with a different value, like let's say int number of students. Or let's say number of team members. So let's pretend we're like working in a sporting context and we have 6 team members. What I've done right here is I've created a variable, but it is of data type integer, signified by int, and it has a value of 6, which is just an integer. And if I print that out, we can go ahead and get rid of all of this. We'll just print out number of team members. Let's go ahead and run that. Ooh, we have an error right here. Oh, I misspelled number of team members. So we've printed out 6 right here. Now let's say we want to do some math, for example. So we have number of team members is 6 and int teams. You can say number of teams equals 15. And we want to calculate the total number of players. So what we can do is we can work with both of these values. We can create another variable and we can say int total players equals number of team members times number of teams. So what we're basically doing is we're using the values of these variables to get a value which we can then assign to another variable. Then we can print that out. We can say total players. Run that. We got an error again. I forgot my semicolon right there. Run that. Another semicolon. You're probably going to see me doing that a lot. Okay. Now we've got an output of 90. What this really meant is that we did 6 times 15, and then we assigned it to a variable total players, and we printed that out. So again, I just want to remind you that these programs are really working in sequence. So we're executing this line, this line, this line, and then this line right here. And that's another example of how we can work with variables and what the role of variables really are. So that being said, I kind of went off on a tangent. What I want to do now is I want to explain to you what constants are. So let's say that in the sporting context, the number of team members never changes. Well, okay, let me do something right here. Let's say that I had number of team members right here, the number of teams, and then I decide to change the number of team members, okay? So I change number of team members right here equals 7. Okay, then I run that. So I've changed this before I've conducted this operation right here, with the star meaning multiplication, if I didn't make that clear before. And we've got an error right here. Cannot find symbol. I have to capitalize this right here. I'll explain why I write it this way in a second as well. So we've got 105 right here because we initially assigned 6 to number of team members. Then we changed the value. So when we went down right here, we multiplied 7 times 15 instead of 6 times 15. Okay? But so this is a scenario again where we could change the value of a variable. But what I want to do is I want to talk about constants and this final keyword right here. So let's say that when we write this program, we don't want the number of team members to be changed at all in our program. We want to make it a constant. So the number of team members will always be 6 and nothing else. Then we can add final right here. And that means that we can never change number of team members. the value will always be 6. That's an example of a constant. Now let's run this and see what happens. Because keep in mind that we did change it right here. So see, now we get an error right here on line 5, which corresponds to line 5 right here, and cannot assign a value to final variable. So we get rid of this, and we get 90. So what we have right here is a bit simpler. Now we have final int animal age equals 53, and then we try to change animal age right here, and then print it out. Obviously, this line of code, or this block of code, would throw an error, because we're not allowed to change the animal age because it's already been declared to be a constant or a final. And so basically what we've seen right there is, so far we've seen what variables are, and we've seen examples of variables that we can and we can't change. Before we move on, what I want to do is I want to talk about what CamelCase is. I mentioned it a couple of times, but I never really explained what it was. Now, CamelCase is really just a way of writing variable names. If you see right here, this variable name has 4 words in it: number, of, and team members. But the first letter of the first word is lowercase, and the first letter of the subsequent words are uppercase. That's an example of CamelCase because it kind of looks like camel humps, I guess. Similarly with total players right here, we have 2 words. The first letter of the first word is lowercase, and the first letter of the second word is uppercase. If we wanted to create a variable like, let's say, number of planets, we would do number, lowercase, of, uppercase, planets. Now, this is a style of writing variable names. If you write variable names in a different way, then it'll still work. Your program will still work, but your code isn't going to look very professional. It's better to, if you write it in this format, then you look more like a professional programmer. And honestly, if you write things, if you write things in a different style, it's not going to be bad, but it needs to be consistent. Like, another way of writing programs is also to have underscores, and that's fine too, but you need to have a consistent style. Anyways, without digressing too much, that's what CamelCase is. It's a way of writing variables, and I'll be writing all our variable names like this in the future, and I would encourage you to do the same. By the way, if it's only 1 word, it's just lowercase, nothing to worry about. That being said, let's move on to our next section. So I guess this isn't really our next section, but the next topic we're going to go over is going to be data types. So we've touched on data types a little bit here. We've seen int, and we've also seen the string data type so far. Now, what these are, well, these data types are just literally the types of data we're working with. So they're literally ways to classify data. So an int represents an integer, which is just a whole number. So -7, 99, or 2 are all examples. And we can also work with a double, which is a decimal number, followed by a Boolean, which is just true or false. Now, before I get into the specifics of what primitive and reference data types are, let me just demonstrate these primitive data types, which are int, double, and Boolean. So we've already seen int. I'm not going to mess around too much with it. Let me just kind of get rid of all of this right here. Let's start with a double. So a double, let's say, I guess a price is a good example of a double, right? So that's going to be $3.99. That's just going to be a decimal right there. So double price equals $3.99. And if we print that out, we're just going to get $3.99. Now, what's kind of interesting is if we have int price $3.99, since it's just a whole number, we're not going to be printing out $3.99. Let's see what happens. So we actually have an error right here because we're kind of forcing it to recognize this as a whole number when it's not. So whenever we're working with decimals, we need to use double. And one thing to take in consideration as well is that int data type takes less space than double data type. So our program will perform better if you use int when you need to and double when you need to. So if you have decimals, use double. Otherwise, just use integer if you have whole numbers. Now, let's do one more thing. Let's say we have double price equals 3. Now, normally this would be an integer, but we're making it a double, and so when we print out price, it's still a double data type, and we're printing out 3.0. So we assigned an integer, but because our data type is double, ultimately it's being stored as a double data type with a decimal. Now that's double data type. The next one we're going to look at is Boolean data type, which is a little weird, and it's not going to make much sense until our next section. But with Boolean, we have two options. We're going to say Boolean is smart. Now we can either assign true to our Boolean variable, or we can assign false. And this is without quotes. This is not a string. And Boolean variables are used for us to make decisions in programs. Again, in the next unit, we're going to go into more detail. All you need to know right now is a Boolean variable is either true or false, and is used to allow us to represent whether something is true or not. So is smart could refer to a person, that person is smart, they're not. Additionally, if we print out a Boolean variable, so let's go ahead and print out is smart right here. We're just going to get true right here. So those are Boolean variables, or those are primitive data types. We also have reference data types. Now, reference data types are a little bit more complex, but the main difference with primitive data types are variables are pointing to a memory location. With reference data types, our variables are pointing to another piece of data. So that's the main difference between them. It's not really going to come up on the exam, but it's just worth knowing because if you're going to learn what primitive data types are, you might as well learn what the other side of the coin is. And reference data types are generally going to be strings and then objects, which we're going to talk about later. Now, objects is in reference to object-oriented programming, which I mentioned earlier on. That being said, let's do some exercises in order for us to fully understand the concepts that we've gone over in the last couple of slides. Now, what I'd recommend is that you pause this video and do these exercises on your own, because what I'm going to do now is I'm going to write the code and go through the answers for each of these exercises. So go ahead and pause the video now. Now let me go through the answers. So number 1 is create a variable called name and assign it your name as a string, then print the value out. So that's pretty similar to our first program, or one of our first programs. We're going to create a variable called name, and it's going to be of a string data type. So string name equals my name is a myth, and then semicolon at the end. And then we just want to print it out, system.out.println, and name. Remember, all of this is taking place inside of class main, and then this construct right here. Let's go ahead and run that. Cool, we printed out a myth. Next, make name a string constant. On the following line, try to change its value and see what happens. So remember, to make a string, or to make any variable a constant, we're just going to add final. And I'm just going to try to change the name. I'll say name equals John. It's not anyone's name really. And when we run this, we get an error right here. If you remove this, then we can go ahead and print that out without a problem. Okay, now let's take a look at number 3. Create a variable called price and assign it the integer value 5 without quotes, meaning that it's not a string, it's just an integer. Create another integer variable called price2 and assign the value of price to it. So what we're basically going to do here is we're going to say int price equals, I guess it was 5, yeah. And then we're going to create another variable called price2, and we're going to assign price to it. And that's pretty much it. What we can do is we can print out price2. We should get 5, but we'll just make sure it's the same. And then run that. Cool, and we get 5 because price2 is taking the same value as price. And also, I just want to kind of make sure that it's clear. Int is for integer. Double is going to be for a double variable. String is going to be for a piece of text. And Boolean is going to be for a Boolean variable. Those are all the keywords you need to be able to declare the different types of variables. Now, if you made it this far and you didn't give up, congratulations. This is like the first part of programming. If you found this difficult, check the slides, go back, try to work through the examples, and I wouldn't recommend going ahead until you fully understand all of this, because these are really fundamental concepts. Also, if you have questions, you can ask on the Discord. That's for which there's a link in the description, and you can also just comment on this video. Now, 1.3, section 1.3 is about assignment statements and expressions. So we've already kind of talked about what the assignment operator is, and we've talked about how to initialize and change variables. I just add this in here so that it's clear that we've hit this point on the curriculum. So no need to do anything for this particular section. We're going to move on to another part of 1.3, which is arithmetic operators. Now, we saw this earlier where we did a little bit of multiplication, but arithmetic operators basically allow us to do mathematical calculations in Java. And these symbols that we use to do that are called operators. So you should have seen these before. So I'm just going to give you a quick example. Let's say that we have int a equals 5, or an int b equals 5. We can, if you want to add these, we can say int c equals a plus b. And that's adding them. We print out c, and we're just going to get the sum, so we should just get 9. And I made an error with semicolons, as I always do. If you wonder why I keep doing that, it's because I've spent a lot of time programming in Python, and Python doesn't have semicolons, so going to Java, I mess it up. And also print is a construct from Python, which is why I messed that up again. Anyways, hopefully that won't happen again. Okay, cool. So we've got 9 right there. Now, we can use plus, we can use minus for subtraction, star for multiplication, and then slash for division. Those are basic arithmetic operators. Now we have one more called a percentage sign, or called a modulo, which is represented by a percentage sign. Now what this does is this allows us to get a remainder when we divide two values. Now to illustrate how this works, let's do a little bit of third grade math, let's say. Let's say we want to do 5 modulo 3. So what we're going to do then is we're literally going to think of this as like long division, right? So we're going to have 5 on the inside, 3 on the outside, and we need to see how many times 3 is going to go into 5. So 3 goes into 5 one time, we can do that, and we're going to get a remainder of 2. And this is going to be a remainder because there's no way 3 can go into 2. So we have 1 remainder 2. Now what this means is that 5 modulo 3 is equal to 2. Let's try another example. Let's say we have 36 modulo 7. So similarly, we're going to have 7 right here, and we're going to have 36 on the inside. And how many times does 7 go into 36? I think that's 5. So we're going to need 35 minus 0, 1, and then remainder 1. So that means that 36 modulo 7 is going to be equal to 1. On the other hand, so this is basically how it's going to work in most cases, where the first number is bigger than the second number. You may have some cases where you have something like 2 modulo 5. Let's set that up in terms of long division. So that's going to be 5 on the, or I guess it's going to be 5 on the outside and 2 on the inside. And 5 is not going to go into 2 any times. It's going to go in 0 times. And we're just going to have the 2 left over. So basically a 0 remainder 2. So that means that something like 2 modulo 5 is just going to be 2. So it's just going to be the first number. That's basically how it works. So some of the most common use cases are to see how much is left over after dividing by 2 numbers. This can be, I mean, I guess that's actually pretty obvious. Other use cases can also be if we have a pattern of numbers. and we want to figure out, like, let's say that we have 10 numbers, or we have 10, let's put this in more material terms. Let's say we have 10 boxes, and each of those boxes has colors, and those colors proceed in a pattern. So you have red, green, blue, and then yellow. Red, green, blue, yellow, red, green, blue, yellow. And I guess this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in this sequence, we want to figure out what color the 8th term is. So we know that if we know that 1 is going to be red, 2 is going to be green, 3 is going to be blue, and yellow is going to be 4. And whenever we have a remainder of 1, we're going to have red. A remainder of 2, we're going to have green. A remainder of 3, we're going to have blue, and then no remainder, we're just going to have yellow, right? So let's say we want to figure out what the 9th term is, right? We're just going to do 9 by 4, because this proceeds in a sequence of 4, and this is just going to be 1, because we have 9, 4, 4 times 2, remainder 1, and so that means we know that 9 is going to be red right here. So whenever we're working with sequences, we want to figure out what value a particular number in a sequence matches up to in this sort of scenario. That's one of the more common use cases of using Modulo, actually. I don't see that coming up too much in AP Computer Science, but it's definitely worth knowing. Now, what I want to do is I want to analyze this example. So here's a code example of when we're using Modulo. So right here, we have a variable called students, and that is equal to 9 times 6, which is just going to be 54. So I'll write that here on the side. And then we have a group size of 7. So that kind of means that we're going to have each group of students is going to be 7 students. So if we want to figure out how many students are going to be left over after dividing this number of students into groups of 7, we can use Modulo, right? Because we're going to have 54, 7. And the result of this is going to be stored in the variable leftovers. So if we have 54 modulo 7, 7, 54, I believe 7 goes in 54, like, what is that, 7 times? So we're going to have 49 minus 0, 5, remainder 5. So that means we're going to have 7 groups of students, and we're going to have 5 left over without a group. So presumably we'll have one other group with 5 students in it. And we would just print that value out. What we'd end up printing out is how many are left over, which is just 5. If we wanted to get how many students how many groups we actually have, we can't get that from this expression. But what we could do is we could actually just do students divided by group size and store that as an integer. And this kind of has to do with the next concept we're going to go over, but let's go ahead and let's look at our code to illustrate what this does. Okay, so right here, let's take a look at this code example that we just saw in our previous slide, and let's just go ahead and run it and see what happens. So you have 54 mod 7, and that's going to be students left over, and we're just going to print that out. And so we get students left over is 5. Notice I inserted the string right here with a plus sign so that we had a nice label so we could see exactly what it is that we're printing out. Now, what we want to do is we want to also find out the number of groups that were created, right? Because if we divide 54 into groups of 7, then we're going to have 7 groups of 7 students, and then we just have 5 left over. So the way we can do that actually is we can do int number of groups, and then we can just do students divided by group size. And we can go ahead and we can print that out. We can do system.out.println, and then number of groups. Well, we'll give it a label as well. We'll say number of groups, plus sign, and then number of groups. And then go ahead and let's just print that out. Let's run that. So we have a number of groups of 7. Now, one interesting quirk that I do want to point out is 54 divided by 7 is not 7 exactly. It usually has a decimal. But here, we set this equal to an integer data type. So we're going to get an integer output right here. So when we're dividing two integers using the division sign, we're not getting a decimal. We're really just getting the answer without the remainder. So for example, when we had 54 divided by 7, we had 7 remainder 5. So we're going to get the answer 7. When in reality, if we actually divide these up by each other, like if we do something like this, let's go ahead and run that. So you can see we got a decimal answer right here. Disregard this right here. This involves a concept called casting that we're going to go into later, but it's just worth noting that when we're working with integers, we're going to get integer answers. So we'll just go back to the way things were. And this is a very typical use case along with the sequences stuff that I talked about before. You don't need to know this at the moment, but I would definitely keep it in mind. I haven't seen, like I said, I haven't seen sequences problems before in the AP CS exam, but I have seen questions like this. So that being said, we've spent a great deal of time on Modulo. Let's move on. Now, when you are working with expressions that have multiple values and signs in them, we need to have some order of operation. So let me just show you an example right here. So you have this example where we have people. We have multiplication and addition. Similarly here we have addition and multiplication. Here we have some parentheses thrown in. Now these are types of expressions that show up relatively frequently on the AP Computer Science exam. And if not even in the AP Computer Science exam, even in programming we can see these frequently. Now the way to tackle these is to understand that order of operations is basically PEMDAS. So it's the same thing as in algebra, but without the multiplication. First, we're going to solve expressions that are in parentheses. Then we're going to solve those that involve multiplication, division, or modulo, which is basically division. And then last, we're going to solve those that involve addition and subtraction. Multiplication and division have the same precedence. Addition and subtraction have the same preference as well. Now, when we're writing our own code, it's best to split up calculations in different lines and use parentheses for clarity. But this doesn't always happen in real life. So let's take a look at this code snippet right here. And let's write PEMDAS. Now, with PEMDAS, let's think about what this first expression is going to evaluate to. So we're starting with multiplication, and then we have addition. Multiplication has higher precedence. So 54 times 2 is going to be 108, and then plus 1 is just going to be 109. Or my handwriting's terrible. So that's going to be equal to 109. Now our next expression looks similar, but is not. So rather than doing 54 times 2 plus 1, we're doing 54 plus 2 times 2. So we're going to do this first because multiplication comes first. So we're effectively going to have 54 plus 2 times 2, which is 4, equals 58. Now this last one, stored in people3, it looks like the same as above, but it has parentheses. So purely because it has parentheses around two numbers that are being added together, we're going to execute that operation first. So first we're going to do 54 plus 2, and that's going to give us 108. Or 54 plus 2 is actually going to give us 56, my bad. And then since we have 56, we're going to multiply that by 2. And then we're going to have 112. And that's an example of how we can solve, or how we can understand what the output of expressions with multiple arithmetic operators is going to be. Now if you look at this expression right here, this one is slightly more complicated. But let's break this down again. Let's say we have PEMDAS, or we do have PEMDAS rather. So right here we have multiplication, and then division. In this case, where we have multiple operators that are on the same level of precedence, we're going to go in order from left to right. So we're going to start with 54 times 2. So we're going to have 108 plus 1 times 5. So plus 5 divided by 5. So we're doing this operator first, then this operator, and then we're doing this operator right here. And we're just leaving the addition sign alone. So that's going to give us 108 plus 1, which is going to give us 109. And that's going to be our answer. That being said, let's go ahead and let's go back to repl.it to do some coding. Okay, so let's go ahead and solve this exercise. So what we need to do is calculate the volume of a sphere with a radius of 2.97, which will be stored in the variable radius. Once we do that, we need to store the result in a variable called volume and then print that out. So what I want to do first is figure out what the volume of a sphere is. Like, how do we calculate that? And it looks like it's 4/3 times pi times r cubed. So what I'm going to do right here is I'm going to start out by creating a double to store radius. So I'll just say double radius equals 2.97. Once I've done that, I'm just going to go ahead and carry out our calculation. So I'm going to say double volume equals 4/3. Remember, it's 4/3 times pi times radius cubed. So times math.pi times, we'll get rid of that. It's either math.pi or math.pi. I think it's just math.pi. Times radius times radius times radius. Now we'll go ahead, I'll explain the whole math.pi thing in a moment. Let's go ahead and let's print out the result. Volume. Keep in mind that I'm using parentheses everywhere where I don't have a single term. We'll go ahead and run this. So right here we got 82.3036. Now this math.pi, so math represents a class, and we're not going to learn what classes are yet, but a class for now is a collection of functions. Or a collection can be a collection of some type of data that follows a certain theme. In this case, everything involving mathematical operations in Java. And here we were able to get a value of pi using math.pi. We'll use this later on to get other mathematically relevant values. Basically, we had 4 divided by 3. We calculate the result within parentheses. We had radius cubed, and we just multiplied it by itself 3 times to get the result within the parentheses. We multiplied all of that times math.pi to get our answer right here, storing it in a double called volume. Now, the next thing we're going to talk about is going to be compound assignment operators. That means that the former value, or let's say the current value of x plus 1 is going to be the new value of x. So let's say, for example, we have int x equals 20. So 20 is the current value. So x plus plus is going to result in x being equal to 21. When you do x plus plus, we are taking the current value of x, adding 1 to it, and then making that the current value of x, or the new value of x rather. So let's say, for example, we had int x equals 22, and then we did x plus plus. That means that if you printed out x, we would get 23. So similarly right here, now x after this x is 21. So if we print out x right here, we're going to be 21. But now we're going to do x plus equals 5. So that means x equals x plus 5. The x plus plus we only use when we want to increment a value or add 1 to a value. Otherwise, we're doing plus equals 5. So it's going to be x equals the current value of x plus 5. Well, right here we note the current value of x is 21. So we're going to have 21 plus 5 equals 26. So that means when we print out x now, we're going to get 26. And now we have x star equals 2. So that means we're going to take the current value of x and multiply it by 2. So we're going to have x equals, or our current value is 26 times 2, and x is going to be that. So that means now when we print out x, we're going to get 52. Now just to go back and look at these operators and see a few more examples, let's say that we had, for example, int j equals 23. And we did j plus equals 1. Well, this just means that j equals j plus 1. So that means our new value of j is going to be equal to 24. It's important to note that plus equals 1 and plus plus are the exact same thing. So if we did j plus equals 1 or we did j plus plus, we'd get the same result. Similarly, let's just do another example. Let's say that we had int m equals 37. And we did 37 star equals 3. That means that what we're saying, actually, let's say we had, sorry, that's not right. Let's say we had m star equals 3. So basically what we're saying is that m equals the current value of m times 3. So that means that now m is going to equal 37 times 3, which equals, what's 37 times 3? I'm terrible at math. 111. Same thing with division right here and subtraction right here. If we had int, let's say f equals 21, we did f minus equals 2. That means the new value of f is going to be the current value of f minus 2, so 19. If we print out f now, we'll get 19. That's how compound assignment operators work. So at the moment, we're not really going to use them. It's not really something that is quite useful, or that's really, I would say, commonly used outside of working with loops, which is what we'll look at probably in 2 units. For now, you just need to know how these work and what they evaluate to. Okay, so now that we've kind of meandered our way through those concepts, let's get to our last section, which is on something called casting. Now, previously we learned about different data types like integers, doubles, and strings. Casting refers to the process in which we change a piece of data, or we change a variable from one data type to another. So you might cast from a double to an integer, or from an integer to a double. Additionally, we can also cast strings to integers or double data types. However, in this particular section, we're just going to focus on casting between integers and doubles. Before we move on to some of the other concepts in this particular slide, let's start out with a little coding example to show you how you can practically go about casting. Now, the first thing I want to show you is something called implicit casting. So a good example of that would be right here, where we're going to cast an int. We'll say int numInt equals 42 to a double. So what we've done is we've declared a variable called numInt, and we've initialized it to 42. Now we're going to create another variable of double data type. So we're going to say double num double equals numInt. Now let's see what's going to happen right here. You might be able to guess already. We've kind of seen this before, but let's print out num double and see what our output is. Let's go ahead and run that. And as you can see right here, our output is 42. So it's essentially the same as our integer value 42, but it has a decimal point and a 0 indicating that it is a double. Now this is one example of casting, specifically implicit casting. Now given that this is implicit casting, let's take a look at what explicit casting looks like by looking at an example of casting a variable of double data type to an integer. So what we got right here is we're going to declare a variable called double another double, and we'll give that a value of 3.14. Now what we want to do is we want to explicitly cast this to an integer. So we're going to say int another int, and by explicitly casting, we're going to put parentheses and type in int followed by another double. So we're clearly taking another double, and using this particular piece of code right here, we are changing this to an integer data type and then storing that value in a new variable that we've declared of type int. Let's go ahead and let's print out the result here, and let's see what happens. So we'll do another double, or actually another int. Let's go for that one right there. Let's run that. So we're printing out 42.0 again from this line of code, but right here, we can see that another int evaluated to 3 right here. So what we essentially did is we basically turned the double into an integer, and in doing so, we just cut off the decimal. We didn't round it, we just cut it off. So if we change this to 3.73, I'm just going to get rid of this for a second because we're not too worried about this. Then let's run that again. In that case, we're still getting 3 because we're just cutting off the 0.73. So when we cast from double to int, which is done explicitly, we are just removing the decimal. Now, if you do want to round, a common practice is to just add or subtract 0.5. So if we wanted to round up, we would add 0.5. Because if we added 0.5 to 3.73, then that would be equal to 4.23, and that would just round down to 4. When we get rid of the decimal point, or when we get rid of any of the decimals, we would just end up with a 4, like so. Similarly, if we just did minus 0.5, then we can pretty much guarantee that this is going to be 3.23, and we're going to get 3. Although in this particular circumstance, we don't even really need to do that. So now that we've done that, we've seen that we can explicitly cast from double to int, and we can also implicitly cast from int to double. What I want to do right here is I want to show another 2 examples. Let's say we have another double right here. Let's do some more implicit casting right here, just to kind of see the full range of things we can do. And we'll do int, another int equals int, another, well, we already did that. Let's just see if this works right here. See, there you run into an error. So if we want to go from double to integer right here, if you just try to implicitly cast, then you get an error. So every time we do that, we need to be using explicit casting. So run that again, and we're good to go. Actually, we didn't print anything out. We could just print out system.out.println, but if we didn't get any error message, then we're pretty much good to go. Just run that again just to be sure. Cool, we got 3 right there. So just keep this in mind. If we are now just going back to, now this is also an example of explicit casting. Let's see what happens if we try to convert from an int to a double using explicit casting. So let's just move this down here. Let's get rid of this. And let's move this down here. And let's say that we have int numint 42, and we just try to really use explicit casting. Let's see what happens. We'll print out num double. So there we got 42.0, and that worked. So what we can conclude from this is that explicit casting works all the time, and implicit casting only works when you want to convert from an int to a double. Explicit casting is all the time. So that being said, if you don't want to get confused between the both of these, then it might just be easier just to explicitly put the parentheses as well as the data type that you want to change it to whenever you're trying to cast. That is the easiest way to do it. I just wanted to show you both ways so you don't get confused when you see that code. Now that we've kind of gone through the mechanics of actually casting a variable from one type to the other, there are a few other things that you should know. So firstly, an integer is 4 bytes, which is less memory than a double data type. So a double data type inherently takes up more memory, which is why if you have a value that's always going to be an integer, like number of people or number of cars or something like that, then it's better to use an int because that means your program is going to take up less memory, which means it's going to run faster. And a professional programmer always takes performance into consideration. Now, partly because an integer is only 4 bytes and only takes up a limited amount of memory, there is a minimum and maximum value that an integer can be. And that's true for double as well, although for double it's not really a big deal because it's an astronomically high value. So let's try doing something like this. So these minimum and maximum values of integers can just be utilized like that. So let's print out system.out.println. We can just do integer dot min value. We'll also print out the max value. You can see these right here. It's pretty big numbers. Our min value is going to be negative this and positive this. And if you try to create an integer greater than that, so let's just do +1 to the max value right here. That's actually kind of strange. It just went back and it just became negative again. So generally, if you have a value that's significantly bigger than the max value, then you're just going to have what's called an integer overflow. So let's try something like that, which I probably will throw an error. Yeah, so right here you're getting an error that says integer number too large, which is also called an integer overflow. Now, I'm pretty sure, I haven't tried this, but I'm pretty sure we can find the minimum and maximum value for a double as well, because that definitely exists as well. It's a substantially larger because a double takes up more memory. Okay, yeah, so that's pretty big. So this is going to be the minimum double value is going to be 4.9 times 10 to the negative 34th, and the maximum is going to be 1.79, etc., times 10 to the power of 308. So unless we're doing some like really, really hardcore calculations, we're probably not going to be exceeding those values. That being said, when deciding which data type to use, you want to take into account, obviously, firstly, the type of data you're trying to represent. But secondly, if you're working with large values, then you want to think about what the maximum value is of an integer and whether you're going to be exceeding that. So we've basically gone through the mechanics of casting from an integer to a double and back and forth. We talked about implicit and explicit casting, and then we talked about memory. This right here, plus 0.5 minus 0.5, we talked about in trying to get our values to be rounded in the direction that we want them to be rounded in. So that's pretty much casting. Let's move on to, well, this is just another example like we went through. Let's move on to an exercise involving casting. Not necessarily involving casting, but kind of involving the different concepts we've gone through. This one specifically involves the modulo. So right here it says we have 23 eggs and we want to sell them in groups of 4. Write code to answer the following questions. How many groups can we make, and how many eggs will be left over? So let's start out with how many groups can we make. This is where casting comes into play. So we're going to say that we have int number of eggs equals 23. And then we have int group, let's say group quantity equals 4. Now, 23 divided by 4 is going to give us a decimal. However, if we just do int number of groups equals 23 divided by 4, then that decimal is automatically going to get cut off to give us an integer value. This is an example of implicit casting right here. Now, we don't really need to worry about rounding because okay, if we just think about it, right, we're going to have about 5 groups of 4. And anything above 5 groups and less than 24 means that we need another group or it's just not going to fit. So we're not worried about rounding. We just want to get the maximum number of groups that will fit into 23. Therefore, cutting off the decimal, cutting off any remainder is totally valid in order for us to solve this problem. So we can go ahead. So we want to calculate the number of groups we can make, which is what we're doing right now. And we can just say system.out.println is number of groups plus number of groups right there. Now, in order to find how many eggs will be left over, remember we can use that little modulo we talked about before. So we're going to say int leftovers. Basically, what we want to do is we want to divide 23 by 4 and then find the number of eggs that's left over, right? So leftovers is just going to be 23 %, 4. And then we can just go ahead and print that out. So we can say system.out.println leftovers, and then plus leftovers. Let's go ahead and do that. Let's run that. Cool. So we've got 3 eggs left over, and we have 5 groups of 4 eggs. So that's a pretty simple problem solved using some of the concepts that we went over earlier on. We made use of implicit casting. We also used the modulo operator, which is probably slightly different from some of the other operators that you may have seen in math class or you're already familiar with. Here is a short answer question. So actually now what we're going to do is look at some exam style questions and then a programming exercise to wrap things up. Okay, so right here, what we want to figure out is what does the following segment of Java code print out? So we have a variable of double data type, and that's x. So x equals 4.5, and we know that we're going to be casting that to an integer. So we're using explicit casting, and remember when we do explicit casting, we simply just cut off the decimal. So that means if x equals 4.5, and we're going to cast x to an int, that means that y is just going to end up being 4, because we're just going to get rid of the decimal point. We're going to get rid of that 0.5. So that means we're going to be printing out 4.5 plus space, and then, well, we're just going to be printing out 4.5. We're going to have a space, and then we're going to have 4. And that's the answer. When you cast a double to an int, it truncates the result. Now next, what does the following segment of Java code print out? So this is a bit more complicated, and we're using something called if statements, which I'll explain here. Now, this is going to be like these if statements that you don't recognize. We're going to be going over them directly in the next unit. So this is actually a great way to kind of give you a bit of a head start on what we're doing next. So right here we have x equals 7, and we have y equals 3. Int z equals x divided by y plus x modulo y. So basically what that means is that we're going to have an integer. So int z is going to be equal to 7/3 plus x mod y. So if we do 7 and then 3 goes in 7 twice with a remainder of 1. So it's going to be 7/3 plus 1. So that means that z is going to be equal to 2 1/3 plus 1, which is going to be equal to 3 1/3. So 3.33. So given that z is an int, remember z is an int, when we accomplish this calculation right here, we're just going to end up with z equaling 3, because we're going to cut off this decimal. And also just remember, what we did right here, the process we went through, is directly related to order of operations that we talked about earlier. We did the division first, and then we did the addition after that. So z equals 3, x equals 7, y equals 3, and z equals 3. Now in our next block of code right here, we have if statements. And if statements allow us to make decisions in our program. So if z is equal to x, we're going to add 1 to y. Remember, using our compound operators. So we know z equals 3, we know x equals 7, and they are definitely not equal to each other. So we're not going to do anything right here. It's only if z, which is 3, was equal to x, which is 7, that we would do this action. However, right here, in our next statement, we're being told if z is equal to y, then do x plus plus. So z and y are both 3, so this is true. So we can do x plus plus, which is just going to make x equal to 8. So because remember, we're just going to be doing x equals the current value of x, which is 7, plus 1 equals 8. So right here, that means x is going to be equal to 8. So we're going to end up with a final value for all these variables of, we're going to have 8, 3, and 3. And that turns out to be correct. Now, I thought this was a really good question because while we did have some stuff that you haven't seen yet, the if statements, still, this kind of forces us to tie together all the concepts we went over in this tutorial so far. Now, that being said, let's go ahead and let's finish off this particular lesson with a programming exercise that is probably a bit more practical. So what we want to do is we want to write a program to convert a Celsius temperature to Fahrenheit. So the first thing we want to do is we want to create a double variable called Celsius and assign it a value of 53. So I'm going to go ahead and get rid of all of this. And so what I want to do is, let's see, a double variable of Celsius. So I'm going to say double Celsius equals 53. Now this is technically an integer, but this is what the instructions are telling me to do. Now to convert temperatures in degrees, Celsius to Fahrenheit, you multiply by 1.8 and add 32. And so we want to do that, and then we want to store a result in an integer variable called Fahrenheit. So we're going to do int Fahrenheit equals, let's say Celsius times 1.8 plus 32. And remember, we're dealing with a double right here. So to be on the safe side, we want to, in order for us to be able to set this equal to an integer of Fahrenheit, we're going to use some explicit casting. So we're going to do this right there. Now what we're going to do is we're going to go ahead and print the result to the terminal. So we'll just do system.out.println and then Fahrenheit. Let's see what happens. Okay, we have an error right there. I missed a semicolon, which I predicted would happen. So yeah, okay, let's go and do that. Okay, cool. We ended up with 127. Now, there wasn't really, like in my instructions right here, I said whole numbers are easier to make sense of. Now, there's not really like a good reason why you'd want a whole number. I just threw that in there to get you to be able to practice casting. One thing I did forget to mention is that with these exercises like this one, you should have just paused the video and done the exercise. It's always better to do these before you look at the answers, because whether you can do them on your own or not is a test of whether you really understood the material that we went over. That being said, that is the end of this particular lesson. Now, this is the first video I'm making in the series. If you found it helpful, please be sure to leave a comment and like and subscribe to this channel. Have a nice day.